Hi everyone! Today let's talk about very big popular topic is machine learning, generative AI, and if it's gonna be a threat for your work, what it can do, how it can, let's say, work in general, what are the challenges there, and of course in particular what the outcome can be out of it. So let's go step by step. In general, to start from something, let's talk what is that. So machine learning, it's basically a subset of the artificial intelligence, and it's just utilizes the algorithms to analyze large data sets and to produce reactions or predictions based on the learning. And the difference of the machine learning versus the normal programs is that when developers making the program, they try to imagine scenarios and normal workflows, how to work with the system and what can be the solutions for particular tasks. Yeah. In case if a developer cannot foresee a particular issue, then of course the program is not ready to solve a particular class of tasks. So usually programs are very specialized things and they cannot go beyond the limits which were designed by the developers. Unlike of that, the machine learning and the models can generate the new rules. And basically, to produce new outcomes, it can try to find out the patterns, and even if something was not programmed, they might find out the way how to solve it. So basically, they under some conditions, they might even create their own rules and even own reality, which is actually called sometimes as a hallucinations or bias. So this is like pretty much tricky moment. We will cover it a little bit later. What is generative AI? I mean, of course, we covered a little bit machine learning, and you could hear within last year, generative AI, like everywhere, like you just search in the internet, like you can see a lot of articles about that. There were, let's say, hardware presentations, and there were like all of the big manufacturers that have mentioned it. You can see even labels on the mobile phones, AI, like things like that. So it's not going to be solved if you cannot put the AI label. So what is that? Actually, it's super simple in general. If we could try to summarize or generalize the things, generative AI is just something what can generate. Yeah, so it utilizes machine learning and it basically uses behind the scene the deep learning algorithms, and it's not only does the analysis and potential predictions in data or based on the input, but it also can try to generate the new content based on the requests. And new content here can be images, can be videos, for example, can be translations, maybe composing of the music. So there can be really a lot of different things. And basically that's about it, about generating new things. Is it new or not? In general, no, it's not new. Machine learning have appeared like for ages already. There is a lot of different programs, algorithms which can handle the learning and deep learning logic. For example, when you was playing computer games, you could see sometimes in the marketing that like companies were or marketing teams were advertising their logic that like exactly in this new version of the game they're gonna be a new AI which will make you play, let's say, more complex. So you will play against of the bot or against of the machine like it's a real human that will adopt on your scenarios and whatever. So well, time passed, and have games changed too much? Do you really feel that you are playing like against of the human? Not really. That's the reality. And in some cases, I would even tell that in some cases there was so much frustration from the gamers and from the community who were using the games that the developers actually were switching and mixing up procedural, for example, or just programmed logic in the NPCs in the game, and try to mix up with a little bit of the AI to give a try to predict something. So I would tell that in most cases there were a lot of things with the AI. There were a lot of, let's say, hypes in the past, especially when people tried, or marketing teams tried to sell the games. But at the end, in most cases, we are not yet there. We are way too far from, let's say, computer be able to emulate a human during playing, for example. Like there's a lot of different AIs. Like generative AI is not the only one. There, for example, predictive AI can be in place. There are the different models available. So generative AI is not something extraordinary. It just became popular right now. And when we talk about generative AI, in most cases, like you could hear a lot exactly about the LLM, which stands for large language models. It's a type of artificial intelligence which is can recognize and generate the texts or any kind of other outcomes. For example, usually it's about the text at the end. They are trained on huge data sets, and thereby they named large. Basically, it's just a computer program which is behind the scenes still using the deep learning algorithms. It tries to recognize and interpret sentences, words, or words into the sentences all together to somehow understand what is asked. So it's still used behind the scene, the probabilistic approach. It's trying to find out the potential probability, what was behind the scene, what is needed to be provided as output. And basically it's just it's in most cases it's just a way how to connect your question to particular data which is saved somewhere in the model behind the scene. If you need to imagine like what is training of the model looks like, usually it's like in a school. You take a small kid, you put it in the school and like make the kid to learn. Let's assume the kid even doesn't know the language. But it just sits and try to go to the text, maybe someone showing the picture, and then the kids start to understand the language slowly, learning the language, like let's assume like kid have appeared in the foreign country. So it tries to learn the rules with the help of the teacher, and basically it's kind of similar happening when we talk about also machine learning and the large language models at the end. When we talk about big models, I mean, of course, it's pretty hard to train them. I mean, you can imagine the kids that you need to feed really a lot of information to the kid to be able to get something meaningful out of it. But with the help of the teacher, for example, and with, let's say, with some fine-tuning, you can get something what exactly you need. When you ask something or force something in the system, you generate in particular requests, and this request is called prompt. So when you hear next time prompts, you understand that it's just type of the question to the model. And yeah, that's pretty much it about the LLMs in general. So, like, very briefly, what has appeared right now? Well, that could be a bunch of answers, and of course my answer is not limited with that. But what I can immediately imagine is that right now we have enough computing power to host the simple, let's say, models, or even sometimes pretty big models, even on the generic devices of the users. This is on the one side. So like every manufacturer of the hardware, they like push in more and more. At some point they find out, let's say, new limits of the hardware, just reducing the size of the components, which allows to get a bit more, let's say, power with the less energy consumption. So at the end, everything leads that we have a little bit more powerful hardware on the one side. On the other side, well, the hype around the crypto mining have finished. You remember how hard it was to find out a few years ago any graphic card which had enough VRAM or graphic like RAM on the graphic card. it was super hard, just because a lot of people, or like even companies, sometimes were purchasing a lot of graphic cards when it was possible, and were mining just to get some cryptocurrencies and make money out of it. This hype have finished because of change in the algorithms, how the, let's say, hashes are generated in the blockchain, or in some of, let's say, most popular or the most expensive cryptocurrencies, and that's basically the idea was killed. Plus, energy rises, like energy costs rising. So basically, the idea of having, I don't know, like a rig with a lot of graphic cards already made no sense. And for manufacturers, it was like, it made total sense to shift people, let's say, attention to something else. And obviously, that under these conditions, well, the perfect candidate might be exactly machine learning, because it's very, very demanding when you talk about training the systems, when you talk about creating your own model. But for the end consumer, it's still pretty much okay-ish. You can even find out that like a lot of labels on let's say, your mobile phones, for example, or new phones, that all of them claiming that they can handle some kind of AI things. So like in the MacBooks, for example, like in the CPUs, there is like additional cores which is available for, let's say, the model. So they are pretty much efficient when they're working with the artificial intelligence, with models. So yeah, this hype was kind of pretty much logical. One hype had finished, time to open a new one. And of course, as soon as manufacturers of the hardware have opened the hype that like we have computing power and there is some models available, so time to jump into the train, then of course software developers who working with that, they also jumped immediately to the train to provide the software for that. And of course there appeared also companies who like provide you the hosting and possibility to actually host your models and to provision them on the production systems. So there was like, it's basically the whole ecosystem. So it's like a Pandora box. You open one thingy and then you have a bunch of other things like opening around. So that's the building of the whole ecosystem. And it's a lot of money at the end. So it's not that cheap in general. And I'll actually show why it's not that cheap. But as you see, so that's a very good opportunity to attract new customers, open the new areas for the manufacturers, for the software engineers, for the companies who provide services. So there's a lot of things around. Plus, it's very strong from the marketing point of view, like when we talk about business developments. I also will cover it as well a little bit later. So, like, if we talk first before, like, any kind of issues, problems with generative AI, how AI can help us. Well, I mean, it's already in the current state, can help to write some simple source code. Yeah, sometimes with errors, sometimes with issues, but still it can help with doing it. It can create texts, generate images for you. It can produce some templates. So it's pretty strong already, even in the current conditions, even with the current issues. And it can also support with data sets analysis. So like you feed a lot of data into the system and ask, for example, what was, I don't know, under these conditions, and the system might reply you that, like, for example, at this time was happening this, or something like that. So it can, as you can imagine, it can speed up quite a lot, checking of the documents, of the big, let's say, like piles of papers. It can help with automations of the routines and the generic tasks, which can be technically easily automated. Maybe even with the making summaries out of the big texts and things like that. So there's quite a lot of things can be done. And of course, it even might help you in generating some ideas. Like what to do next, maybe like which interesting areas might be in place. Let's assume just, for example, creating of the product description on the e-commerce shop. You can just take manufacturer description, feed it into the AI, and then say that, okay, now please generate me new description based on that. And it will generate. So yes, of course, you will need to read it, you will need to double check, but you can get a base or kind of template, and then you can build something on the top of this afterwards. So pretty interesting already directions are opening with the generative AI. And of course, there will be even more at the end. Like, as I mentioned also in the past, like images creation, even videos creation, whatever. So creativity of human who can try to use generative AI might be like very high, let's call it like that. But you remember there's some kind of issues. I mean, of course, there's a lot of nice music, there's a lot of nice things around, a lot of promises around the AI. What are the problems? Let's take a look at the other side of the coin. You remember I mentioned that it's pretty easy to launch the model, make it working. It's like we have more computing power for the generic users. But forget about that if you need to train your own LLM. It's gonna be super expensive. It's very expensive process. So on the one side you can have a consumer, so people who can use the model. On the other side you can have people who are basically building this model, so training them. And this process is very intensive and super expensive. Just for you to understand why like mid-sized companies will not be able even to afford to train own LLM. For example, you can search actually on the internet as well, you can find out, but even according to some, let's say, papers like from the Llama, they trained the model, which was I think they used around 13 billion of parameters, and as an outcome they got only they trained model with 13 billion of parameters, and to get it they had to fit into the system around 1.5 trillion of parameters or words. Let's call it like that, words. So as you can see that the proportion, how much data you need to fit into the system versus like what you get in the training afterwards is pretty big. And basically they mentioned that, for example, to train this 1 billion parameters model, they spent around 21 days. And during this time, they had to use around 80 graphic cards, which are specialized for this type of the tasks. There were, I think, NVIDIA H100 or H200. So these graphic cards are that special because they have, let's say, like really a lot of RAM and additional cores for actually which are focused actually on working, not on the rendering, but on the calculating the things. And basically, I mean, you can imagine one of these cards, which has like around from 40 to 80 gigs of RAM, it would cost from 10,000 euro until 20,000 euro. So you can see, and if we talk about like around 2,000 of graphic cards like that, we talk about millions in investments just only in the hardware and infrastructure here. We even don't need to count the amount of electricity which gonna be burned during like 24/7 working and training for the model. So you can imagine, it's super expensive process, and only like very big and fat guys with enough money can handle it. So yeah, it's super expensive process. Of course, immediately people who love cloud solutions, they immediately would tell, yeah, but let's use cloud for that. You don't need to purchase the hardware. Take, I don't know, Amazon. Take Microsoft Cloud or like Google Cloud. Wonderful. No, not that easy, definitely. Thing is that yes, they do provide you this computing power, and you're gonna pay for either hours or for tokens. And like as I mentioned, like you sometimes need to fit trillions of tokens to get a big model with billion of parameters afterwards. Well, I mean, just imagine you pay per token or per set of tokens. It's gonna be like super expensive at the end. Basically, in average, usually when people talking about the training, you can just imagine, I don't know, you have document with 1,000 of words. And as soon as model works with tokens, in this case, or with the parameters, basically each document gonna be split automatically into the pieces, and usually increase in the size is around plus 30%. So let's assume again, like you have 1000 symbols text, and it's gonna produce you around 1300 tokens at the end. Just for you to get it easier, for example, word cheating. It's one word. On the other side, you will get two words out of it, like cheat and ing at the end. And this is how it works. So at the end, you might, like when you use a model aggressively with a lot of, let's say, different words for analysis, it will become very pricey very quickly. And if we talk about training, then yeah, it's gonna be super expensive at the end, because we talk about huge amount of data which you need to first get somewhere, then send it there, pay for that, and then get it backwards. So yeah, it's not that easy, as I mentioned. So cloud solution most probably will not work, and it's already like confirmed that it's much cheaper to have own hardware than use cloud solutions for that. You can find out some kind of researches, but usually it's proportion 1 to 10. So it's much cheaper to have own one. But for hosting, yeah, for hosting might be a good solution to keep for a short time on the public, but still, when you have a chance to purchase, then you better still to purchase under some conditions, at least currently. So as you see, on the one side, for the normal, let's say, people, it might be achievable just to use it. But if you need something special, if you want to build it on your own, then it's gonna be super expensive and requires millions in investments to build large model. Yes, to balance it, there have appeared the small models, or it's called SLM, small language model. The idea here is pretty much same. You train the model, but it's much smaller, so it can understand the language, but it will not be that let's say knowledgeable with that broad let's say skills in understanding different languages or different subjects. So they're gonna be specialized on particular area, but this is most probably a way to go for smaller companies, and it's still gonna require pretty big investments to be able to have own model, even small one. So not that easy, as you see. It sounds on the paper easy, not that easy when you try to use it.